Hello children, today we will discuss about the chemical properties of base. In previous video, I told you all how bases are prepared generally. Now tell me to discuss about chemical properties. So first chemical property of base is they absorb carbon dioxide. They absorb carbon dioxide gas to form metal carbonate, right? So bases absorb carbon dioxide gas to form metal carbonate. For example, when sodium hydroxide come in contact of carbon dioxide gas, the CO2 gas is from air. You can say when sodium hydroxide absorbs CO2 gas from air, it forms metal carbonate. Metal is sodium here. So sodium carbonate will form Na2CO3 along with water molecule. So to make it balance, you have to put a stoichiometric coefficient 2 in front of sodium hydroxide. Right? One more example we can consider potassium hydroxide. So when potassium hydroxide absorbs CO2 gas from air, it forms K2CO3 plus water molecule. Right? So first chemical property is when metal hydroxide, base, absorb CO2 gas from air, it forms metal, respective metal carbonate plus water molecule. Right? Now come at second chemical property. Second chemical property is very common, neutralization reaction. So bases neutralize, they neutralize the effect of acid. They neutralize the effect of acid. Right? Bases neutralize the effect of acid and vice versa. In the topic acid, we have learned that acid neutralizes the effect of base. Let's see. For example, sodium hydroxide base. It neutralizes the effect of hydrochloric acid to form normal salt, NaCl plus water molecule. And this reaction is known as neutralization reaction. Right? More example we can see. Iron second hydroxide neutralizes the effect of hydrochloric acid to form FeCl2 plus water molecule. Stoichiometric coefficient 2 you have to put here. Right? So this reaction is neutralization reaction. Okay? Now see third chemical property of base. Okay, so third chemical property of base is related to the formation of precipitate of metal hydroxide. When bases react with heavy metal salt like copper, zinc, lead, they form respective hydroxide in the form of precipitate. Right? For example, copper sulfate is a soluble salt. We have taken a solution of copper sulfate. When copper sulfate solution is treated with reagent sodium hydroxide, here sodium hydroxide is base, right? They both undergoes precipitation reaction to form hydroxide of this metal, copper second hydroxide plus sodium sulfate soluble salt, right? So third chemical property is related to the formation of precipitate, PPT of heavy metal. This reaction, such kind of reactions is very common in the chapter analytical chemistry. We will discuss this reaction again when analytical chemistry topic will come. Okay? More example we can see, when zinc nitrate ZnNO3 whole twice undergoes reaction with sodium hydroxide, it forms zinc hydroxide, a gelatinous color precipitate. If we talk about color of this substance, it is pale blue. Pale blue means light blue. The color of this substance is gelatinous white. Along with the formation of sodium nitrate NaNO3. Two molecule of NaNO3 will form. Right? Similarly, when lead nitrate PbNO3 whole twice undergoes reaction with sodium hydroxide, it forms PbOH whole twice, chalky white color precipitate, PPT, right, plus sodium nitrate, a soluble salt, right? So whenever soluble salt of heavy metals are treated with base, they form hydroxide of that heavy metal in the form of precipitate and salt, right? See, always remember, especially when we talk about zinc and lead. The hydroxide of these metal, I'm talking about zinc hydroxide and lead hydroxide, they further undergo reaction in the presence of excess of sodium hydroxide to form a complex soluble salt. Here, when zinc hydroxide will be treated with excess of sodium hydroxide, it will form sodium zincate Na2ZnO2. This salt is soluble, right? Further, when you will treat this lead nitrate, lead hydroxide with excess of sodium hydroxide, it will form sodium plumbite, Na2PbO2. They both are soluble salt. Aluminium can also undergo similar reaction. Further reaction can take place with aluminium hydroxide when excess of reagent is taken. Similarly, stainless also undergo the same reaction. Clear? Now come at fourth chemical property of base. Fourth chemical properties of base. When fourth property is related to warming of ammonium salt with sodium hydroxide. So always remember, when alkalis are warmed, with an ammonium salt, ammonia gas liberates, right? So when alkalis are warmed with ammonium salt, you can take ammonium chloride, ammonium nitrate. Okay, ammonia gas liberates. Ammonia gas liberates. For example, let's see the reaction of ammonium chloride with sodium hydroxide. Ammonium chloride, ammonium salt. When it is warmed with base, sodium hydroxide. Here base is alkali, water soluble. Heat it. After heating, you will get sodium chloride plus ammonia gas and water molecule. Water molecule. You can see here ammonia gas is liberated. Ammonia gas is liberated. So when alkalis are warmed with ammonium salt, ammonia gas release. Ammonia gas releases. One more example we can say ammonium sulfate NH4 whole twice SO4. Treat it with potassium hydroxide. Potassium hydroxide. Now warm it. Delta is the sign of heat. Now warm it. After warming, what you will get? Potassium sulfate K2SO4 plus water molecule and ammonia gas will liberate. Ammonia gas will liberate. This is all about chemical properties of base. Chemical properties of base. I hope you people understood today's topic, chemical property. Okay. After that, in next video, we will discuss about strength of acidic and basic solution. I mean pH.